Welcome to Sri Learning Academy. Let's simplify process states. When we talked earlier about what a process is, we said that a process is simply a program that is currently being executed. It is not just the program code, but also all the information needed to run it, like its data, its current position in execution, and the resources it is using. Now, once a process is created, it does not stay in one condition forever. From the moment it starts until the moment it finishes, it keeps moving through different situations. These situations are called process states. To understand this movement clearly, operating systems use something known as the process state transition diagram. Think of the process state transition diagram as a simple map that shows the life journey of a process inside the operating system. Just like a human life has stages such as childhood, adulthood, and retirement, a process also goes through well defined stages. Each stage tells us what the process is currently doing and why it might move to another stage. Let us start from the beginning. When you double click an application or run a command, the operating system creates a new process. At this moment, the process enters the new state. In this state, the process is being set up. Memory is allocated, a process control block is created, and the basic information needed to manage the process is prepared. You do not see this happening, but the operating system is doing a lot of background work here. This state is usually very short because the process quickly moves forward. After the new state, the process moves into the ready state. This is one of the most important states to understand. In the ready state, the process is fully prepared to run, but it is not currently using the CPU. This does not mean the process has a problem. It simply means that the CPU is busy running some other process. Imagine a line at a ticket counter. Everyone in the line is ready to buy a ticket, but only one person can be served at a time. The people waiting in the line are like processes in the ready state. They are ready to execute as soon as the CPU becomes available. Now comes the running state. When the CPU scheduler selects a process from the ready state and assigns the CPU to it, the process enters the running state. This is the state where actual execution happens. Instructions are being fetched, calculations are performed, and the program makes progress. At any given moment, on a single core CPU, only one process can be in the running state. On multi-core systems, multiple processes can run at the same time, but each core still runs only one process at a time. A running process does not say running forever. Several things can cause it to leave the running state. One common reason is that the process may request some input or output operation, like reading data from a disk or waiting for keyboard input. Since I/O operations are slow compared to the CPU, it would be a waste of time to keep the CPU idle while waiting. So the operating system moves the process into the waiting state, which is also called the block state. In the waiting state, the process cannot run even if the CPU is free. It is waiting for some event to happen. For example, imagine a text editor that asks you to open a file. Once it sends a request to the disk to read the file, it waits. During this time, it cannot continue execution until the disk finishes reading the data. That waiting period is exactly what the waiting state represents. Once the event the process was waiting for is completed, the process does not immediately start running again. Instead, it goes back to the ready state. From there, it waits its turn to be selected by the CPU scheduler. This movement from waiting to ready is a key part of the state transition diagram. It shows how the operating system efficiently switches between processes to keep the system responsive. There is another important transition to understand, which happens from the running state back to the ready state. This occurs in systems that use preemptive scheduling, which we will study in detail later when discussing CPU scheduling. In simple terms, preemption means the operating system can force a running process to stop using the CPU. This usually happens when the time slice given to the process expires. For example, if two applications are running at the same time, the operating system may allow each one to run for a small amount of time, then switch between them. When a process's time slice ends, it is moved from running back to ready, even though it is not finished. Finally, there is the terminated state. When a process finishes its execution normally, or when it is stopped due to an error or a kill command, it enters the terminated state. In this state, the process is no longer active. The operating system cleans up its resources, frees memory, and removes its process control block. At this point, the life cycle of the process ends. If we now imagine the full diagram, we can clearly see the flow. A process starts as new, then moves to ready. From ready, it goes to running. From running, it can go back to ready or move to waiting or end in terminated. From waiting, it returns to ready once the required event occurs. This continuous movement is what keeps modern operating systems fast and efficient. To make this more relatable, think of a restaurant kitchen. Orders come in and are written down. That is like the new state. The orders waiting to be cooked are in the ready state. An order currently being cooked is in the running state. If the chef has to wait for ingredients, the order goes into the waiting state. Once the ingredients arrive, it goes back to ready. When the dish is served, the order is terminated. This simple analogy closely matches how process states work in an operating system. Understanding process states and the state transition diagram is very important because it forms the foundation for many advanced topics. When we talk about scheduling, context switching, or even deadlocks later on, all of them rely on how processes move between these states. If you are clear about this flow, the rest of process management becomes much easier to understand. That is it for this video. See you in the next one.